Okay, so this is number 4. I'm going to do a fifth problem because I'm going to adjust this one just slightly. This basically is everything going on in it. So I want to show us one more before we kind of get to one that has all of this stuff happening. So let's just knock off this plus 1 at the end. That's just going to give us a vertical shift. I'll show you what one looks like at another time. Okay, so the amplitude is the absolute value of the number in front. So it is incorrect to say -3. It's +3. The negative will reflect over the x-axis. And that's what it does. So the amplitude is a distance, so it stays positive, and that negative just makes it reflect over the x-axis. Now, here we see that there's a number in front of the theta. There's this pi/2 thing. What we want to do to make our lives like really easy is to factor out that 1/2 in front of the theta. That ensures that we get the correct horizontal shift. So if I take a 1/2 out, I'm going to be left with theta, and then I'll be left with pi. If I distribute back through, I get 1/2 theta, and then I get pi/2. So I know I did that correct. And that's just so that we make sure we get that horizontal shift correct, because the horizontal shift is not pi/2, it's actually pi. So we factor out the 1/2 to get the theta by itself. So factor out 1/2 to get theta alone. Okay, so this is the equation we're going to be working with, not this first one. This 1/2 is going to be our b. So period is going to be 2 pi over 1/2, or 2 pi times 2, which is 4 pi. Horizontal shift will be positive pi. That's where we're going to start. And vertical shift, we cut off the only vertical shift we had, so we have none. All right. So we're going to say 4 pi divided by 4. We get pi, and that's what we're counting by. Okay. The last thing that we're going to do is take care of this negative. I'm actually going to graph it without the negative first, and then we'll reflect it, and I can show you what we get. So we're going to count by pi's. Pi, 2 pi, 3 pi, 4 pi, and we'll go negative, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. All right, and then our amplitude is 3, so I want to make sure I go all the way up to 3. So I'm going to count every other. Okay, now be careful. I'm going to graph the non-reflected one first. So I'm going to graph it as if there was no negative. So 3 sine 1/2 theta minus pi. Okay, so we're going to start at pi. That's my horizontal shift that tells us we're going to start at pi. It's a sine function. So sine function starts down at the 0 line. My amplitude is 3, so my next move up is going to go all the way up to 3. I go down, and then at 4 pi, I'm going to go to -3, and then 5 pi would be right here. I'll just continue the curve. All right, we can go negative, so we're going to go negative. We're going to go down to -3, come back up to negative pi. We're going to finish the pattern on the other side. Negative 2 pi goes up to +3, 3 pi at 0. So this looks good. This is 2 cycles. Perfect. Now, this graph here is y equals 3 sine 1/2 theta minus pi. Now, what we want to do to make sure that we get the correct graph is that we're going to just take all these points and reflect them over the x-axis. So if a point is on the x-axis, it stays. But this -2 pi 3 is going to drop down to -2 pi -3. This point, negative pi 0, stays. 0, -3 becomes 0, +3. Stays. So every point that we make gets reflected. So it's going to look something like this instead. Great. So that's y equals -3 sine 1/2 theta minus pi. That's the graph we want. That blue graph is the graph we want. That one that we did in pen just helps us graph the blue one. All right. And I like to make a little indication, like next to the equation, which one is actually the graph. So I have a blue marker next to the equation.